Hello, third graders, and welcome to lesson 6.3. And this week, or with this lesson, we are going to talk about some of the fact strategies we have been using and know about for multiplication. But first, some quick look cards. Now, when you see this, I don't want you to think about how many dots you see. I want you to tell me how you see those dots, like a number model that would go with what you see. So, for example, what'd you see? I saw, well, here we go, Mrs. Flurry, come on. I saw two groups of 9. So I saw 18. Now, I also, again, saw a group of 9 and a group of 9, which is also 18. Let's see if I'm correct. Yep, 9 and 9. Two groups of 9. So that's what we're going to do. Here we go. Try it again. What'd you see? And how did you see it? And what number model might work? I saw 4 groups of 4. And I know that that is 16. Could also be 4 groups. I saw 4 groups, and there were 4 in each group. So 4 plus 4 plus 4 plus 4, 16. Yep, that's what I saw. Last one. Ready? Here we go. Ooh, what'd you see and how did you see it? Well, I saw 3 groups of 4, and that's 12. Yep, one group, second group, third group. But I can also go, if I'm looking at it up and down, I see 4 groups of 3, so 4 times 3, which is also going to be 12. Do you remember what we call facts like this? 3 times 4 is the same as 4 times 3. We call those turnaround facts. Okay. You're going to need your whiteboard marker and eraser. I've got a little problem I want you to take some time to think about and how you got an answer. So Evan does not know the answer to 6 times 7. Record at least 2 different strategies that he could use to solve 6 times 7. Think about some of the strategies that we've talked about. Take some time. See what you can come up with. Pause the video. Come back when you have that finished. What strategies did you come up with? Here's what I came up with. So I want to figure out 6 times 7. I'm going to use add a group strategy. I'm going to use the helper fact 5 times 7, which is 35. And then to that 35, I'm going to add another group of 7 to get 42. And why am I going to add 7? Well, I want 6 7s. I know what 5 7s are, so I need to add another group of 7. My other strategy that I'm using is doubling. I really like this strategy. So I know that half of 6 is 3, so I can take that. 3 times 7 is 21, then I can double that. Because if 3 times 7 is 21, then 3 times 7 is 21. I can add that together and get 42. And that's my answer to 6 times 7. So let's review some of our strategies that we've used so far. We have used so far this year adding a group. Now, if I want to know what, I'm going to use a different problem besides 6 times 7. What if I want to know what 7 times 8 is? I can make an array for 6 times 8. I can make that array. Okay, so I can do my array for 6 times 8, which is 48. And then I can add one more row. Count those on. So that was 48, 49, 50, 51, 52, 53, 54, 55, 1, 2, 3, 4, 5, 6, 7, and 58. 56. Mrs. Flurry is losing her mind today. So 7 times 8 is 56 by working with the strategy, adding a group. Another strategy to use could be doubling. We did it before for 6 times 7. What if I wanted 8 times 9? All right. Well, I could use doubling, and I can go 4 times 9 is 36, and then add another 36. 6 plus 6 is 12. That's going to be 7 tens, so my answer is 72. So when I use doubling, I take half of that even number, which is 4, find that answer, and then double it or add it to itself. Near squares, we worked on that a couple weeks ago. So I can use near square. Let's see. Let's say I wanted to know 5 times 6. Okay. Or I wanted to actually know, well, that's not a good example. Let me move back a little bit. Here's a better example. If I want to figure out 8 times 7, I can think about what square is it by? Well, it's by 8 times 8, and it's by 7 times 7. I really just want to use the one that I think I know the answer to, so I know 7 times 7, which is 49, all right? But I want another 7, because I want 8 sevens. This is 7 sevens. So I add another group of 7 to that, and 49 plus 7 is 56. So 8 times 7 is 56. We worked on the break apart strategy, okay? So I'm going to go ahead and do it for 6 times 7, but when we did it, we made rectangles. It's a great tool. So I can make my rectangle, label one side 6, label one side 7, decide which part I want to break apart. Which side do I want to break apart, the 6, or do I want to break apart the 7? I'm going to break apart the 7. And I'm going to say what makes 7 is 5 and 2. So I'm not going to use the 7 anymore. I'm done with it because I have it down here for 5 and 7. So in my rectangle, I can make number models for 6 times 5, which is 30, and 6 times 2, which is 12. And I can take that 30 and that 12, add it together to get 42. Let's do another, since this one's kind of new. And I want to figure out 7 times 9. 7 and 9. I'm going to break apart the 9, and I'm going to use 5, and I'm going to use 4. I'm going to cross off that 9 because I'm done with it. Number model 7 times 5 equals 35. 7 times 4 equals 28. I'm going to take my 35 and my 28 and add those together, and I'm going to get 63. So that means that 9 times 7 equals 63. So the break apart strategy, it's a really fun one to do to help you figure out multiplication facts. Okay, so now how can we use doubling to solve 9 times 7? Guess what? We can't use doubling, can we? Okay. Doubling will not work because neither fact is a double, which means I cannot take 9 or 7 and make it be half. One of these would have to be an even number. So if this was 9 times 4, I could do that. because I could say, well, half of 4 is 2, so 2 times 9 equals 18, and 18 plus 18 equals 36. But I cannot do it for two odd numbers. Okay? So, for strategies to help you figure out times 2s, times 5s, and times 10s, we can skip count by 2s or by 5s or by 10s. So, for example, if it was 7 times 5, I could skip count 5, 10, 15, 20, 25, 30, 35. And if it was 10 times 7, I could skip count by 10s. 10, 20, 30, 40, 50, 60, 70. Other strategies we've used when we multiply by zeros or ones facts. All right? For an example, I can think of equal groups to help me solve 0 times 5. 0 groups of 5 means no groups, which is just 0. Okay? And what we've talked about, anytime you multiply a number by 0, you always and forever get 0. And anytime you multiply a factor by 1, you always get the other factor. So 7 times 1 is 1. 15 times 1 is 1. 17,000 times 1 is 17,000. Okay? 1 times 0 is 0. 5 times 0 is 0. 20 million times 0 is 0. Strategies for multiplying squares. Well, I can sketch a 4 by 4 square array and skip count by 4s to solve 4 times 4. So let's try this. I want to figure out 3 times 3. I made an array for 3 times 3. I know there's 3 in each row, so I can just skip count 3, 6, 9. Oops. We have that turnaround rule, which we've worked on before. So I know that if 7 times 3 is 21, then 3 times 7 is 21. The example they're using is 5 times 8. Here's an array for 5 times 8. I can turn that around and have it be 8 times 5. And I'm still going to get 40. Add a group. So if I want to know what 3 times 8 is, I can use my helper fact because I know that that's 16. So I start with 2 groups of 8, and I want 3 groups of 8, so I have to take my 16 and add that other group, and I'm going to get 24, so that means 3 times 8 is 24. So if I want to know what, let's say, 6 times 7 is, my helper fact is going to be 5 times 7, which is 35. So I'm going to add a group of 7 to that, and I'm going to get 42. So 6 times 7 is 42. We worked with subtracting a group. I want to know what 9 times 6 is. I don't know that, but I know 10 times 6. So I can figure out 10 times 6 and then take away a group. Same thing. So if I want to know what 4 times 7 is, I don't know that, but I know 5 times 7 is 35. So I need to take away a group of 7, and I'm going to get 28. I can do that with making an array. Make an array for 5 times 7, and then just crossing off my last group. Okay. What strategy is this? Oh, this is the double strategy, isn't it? This is another example of doubling. Because if I want to know what 6 times 4 is 24, but then I change my mind and I want to know what 8 times 6 is, then I just need to draw another rectangle with the same measurements. And I'm just going to double what I already had. And this would be what? near doubles. So if I want to know what 8 times